Good afternoon, good evening, or good morning, wherever you are in the world. Thank you for joining us back at the Safety and Human Factors webinar. Today, we're at the fourth webinar with the Professor Guy Andrebois on the use cases of human safety integration from different industries. Before I give the floor to Guy to start the webinar and the lecture, a big warm welcome on behalf of all Eurocontrol team. Clar, who is in the support of technical staff, Stein, and I include that also Jörg in Eurocontrol team. He's freshly retired from DFS, but he will continue to help assisting us in putting forward this webinar. So welcome. Just to let you know that I'm working with Jörg to build up the new list of webinars, and we'll have a couple of weeks to finish it, and we will publish it, and we'll have webinars until the beginning of next year. So without further ado, I think Guy doesn't need any introduction. Just to refresh a bit our memories, we started in September with an evolution of automation. Then we followed in October with the role of people in the interconnected systems, human element in large complex systems. Then in November, we had problem solvings and procedures, how people are handling unexpected situations. And today, from his last and vast activity as an engineer, as a cognitive scientist, as the one who has introduced the cognitive engineering in France and development it in the worldwide. We work for NASA and many other places. Today, it's the practical side, how we use design in cases of human safety and integration from his experience with different industries. So, as usual, we have about an hour with the slides, with the support by Guy, and then we have about 15-20 minutes Q&A. Please use the chat for salutation and use the Q&A feature of the Zoom for putting your questions, and we'll moderate that at the end. Guy, the floor is yours.
Good afternoon. Also, good morning for the people who are in a different time zone, and good evening eventually. So I put my slides. Let's see. Can you see my first slide?
We do, Guy, all good. We see you, we hear you, and the slides are good. We're good to go.
So today I'm going to talk about examples, use cases from various industries. Let me check. So I'm going to illustrate human systems integration using 4 industrial examples. What I'm going to emphasize is the participatory design during the whole life cycle of a human machine system, virtual human-centered automation and tangibility, how virtual things and tangibility need to be run together. Task and activity analysis, taking emergence seriously. You know, how do you deal with emergent properties, emergent behavior, emergent functions and structures? Then also this webinar will anticipate the next 2 webinars, one on scenario-based design, and I'm going to talk about the product experience is anticipated, I think, in June, and also digital twins as design and operation support. So if you are interested in this, I mean, I wrote a book 2 years ago, Human Systems Integration from Virtual to Tangible. So the outline is the following. After a short introduction, I'm going to introduce use case 1, which is in the field of air combat environments. The second is oil and gas. The third is about remote maintenance. Here I'm going to take examples for the maintenance of helicopter engines. Case number 4 is remote and virtual military air traffic control center that we are working on right now. And then I will mention 3 more cases. I will not have time to develop everything, and start the discussion with the Q&A. So for all these examples, we follow this process. First of all, we have what we called, and I defined that in the previous webinars, an outside-in approach, which means that we start from the people and from scenarios and cases to the design of declarative, we call that declarative. We oppose procedural and declarative. We'll see that more detailed next time, and I already introduced that during the last seminar. You know, we go from people to machines and not the other way around. And then this is becoming possible because of the digital media that we have today. We can fully develop an aircraft, for instance, in the form of a video game, you know, and then tangibilize this and go to the real aircraft in the end. So you see where virtual and tangible, you know, happened. So use case one, we call this project Mohican. There is no meaning for Mohican. That was nice to call it this way. There was a research effort sponsored by the French Ministry of Defense and supervised by Thales and Dassault Aviation. This was done in the context of my chair at Central Supélec and Estia called FlexTech. And so we worked on the collaboration between fighter pilots and virtual assistants. So the main objectives were to monitor the human-machine performance by analyzing trust and collaboration, trust of the pilot, trust you know, vis-a-vis the virtual assistance systems. Usually trust and cooperation goes together. So the objective was to propose and test a method to evaluate the performance of pilot virtual assistant teaming. You know, we'll see that later. So in the cockpit of a simulator fighter aircraft, we had a F-14 simulator that we ran. And then the goal was to define trust and collaboration models and metrics. You cannot measure or assess something if you don't have the right model. So in fact, the first thing is to model trust and collaboration. So considering pilots' context and environment, we worked with 7 fighter pilots. And another objective was to build indicators based on operational experience. This was more like a subjective assessment, and building metrics based on tangible virtual prototypes, meaning that we tested that in simulation and developed these virtual prototypes that we call virtual assistant and experiment them. I'm going to show you how we compared also a subjective assessment with objective assessment methods. All this define what we call human-machine teaming. So the method for the analysis of trust and collaboration is presented here. So we started with a task analysis and using a notation called BPMN, Business Process Model and Notation, and a function analysis. I will come back on that. So the first thing was you know, we tried to develop scenarios with fighter pilots. Then we developed prototype based on a commercial simulator of F-14, and then we augmented that during the first year. We ran human-in-the-loop simulation, and we observed the activity. You know, I just remind you the difference between task and activity. The task is what we prescribe, what we try to do, and the activity is what the pilot is effectively doing. So in fact, we need to observe the activity of the pilot and analyze the emergent properties. I mean, detect the emergent properties and analyze the various activities. So after that, we run an analysis of what we call structure function analysis, and potentially we could redesign the system here. So in fact, the HSI, human systems integration objective, needs to be verified if we reach the objective using operational performance models that we are incrementally developing. We start with one, and then this evolves. And then we loop that on what we call the procedural and declarative knowledge management. In fact, we set up at this point, it's a big term, but I'm going to use it, an ontology of ontology is actually the if you like terminology terminology is about terms, ontology is about concepts, but the concept need to be named by terms. So in fact, here we develop this ontology that we re-inject in the loop here. So this first task analysis is done using what I said, the BPMN notation here. And this is what it looks like. I will not enter into details there, but this is, we had walls, big walls of that, and then afterwards, after the simulation, when we observe activity, we do exactly the same with the activity, and we compare the task and activity. So in fact, this product means for procedural and declarative. Procedural is for the description, if you will, the description of the various actions, if you like, the task and activity. And then the declarative is about the structure, the resources, the various means that you have to implement the various functions. So in fact, we start with a task analysis, a task model. We produce a task model. Then we run the function analysis, and we develop a function model. And then we run a simulation of what we want to test. And then we have a performance model that is expressed in three ways. One is the TK, for instance, is the high-level metrics. Like, for instance, here in our case, we have three metrics, high-level metrics: operational performance, trust, and collaboration. And then that are decomposed into CJ, which means criteria. The criteria could be, for instance, the workload, the situation awareness, all these kind of things. And then all these could be decomposed into small measures, I mean, basic low-level measures, MI, that could be the time it takes to push a button, for instance, or the time it takes to solve a problem, or these kind of things. So all this, if I follow the arrows, then we have a performance analysis using this, and then using a reference for that, and then a performance model quality assessment, and then we loop on the activity analysis. All this is was run in the Mohican project 3 times. So in fact, in other words, we have this BPMN development of task and activity. And then we start with what we call as-is scenarios, task-based procedural knowledge. Then we followed by the task-based declarative knowledge in the simulator itself, the 2B. And then we observe the activity in human-in-the-loop simulation. And then we loop on the activity-based procedural knowledge, the 2B, future task, if you want. We transform what we observe into the task to inject in the next simulation because we modify the simulator. So in fact, this is the experimental setup. As I said, we used it's very basic, screens. We had I would say not a lot of money, but we ran that, and in addition, we started that during the COVID period. So that was quite interesting study. So we ran this simulation using a system called TagView, DCS World. I will not enter into. The people who are running this kind of simulation know what I'm talking about, but it would be too long to develop what they can do. But this is very, very interesting because the fighter pilots that actually were involved in this study really liked the simulator. I mean, there was not a real fighter aircraft, but there was realistic enough. So here is a simulation. So in fact, we had the pilots were equipped with eye tracker, so we could actually assess this low-level measure, the MI I was talking about, and did use some criteria and then up to the high-level metrics, if you like. So all this was implemented, you know. So here is the navigation display. Here. We were very lucky because we had a set of 7 fighter pilots who were very, very skilled, of course, in fighter aircraft, but also manipulating the mouse and things, and you know, they were very excited about this this experiment. So in fact, we captured this, you know, the low-level measure using these various methods. Heart rate monitor using a Garmin watch. We found that was better than the other types of measure for the heart rate. We used, you know, the eye tracking, the Toby glasses, and then the Noldes XT observer to analyze the eye tracking. So I will show you. So in fact, here, you know, after the experiment, we could run. We could run, you know, the experiment again and do what we call the self-confrontation of the pilots with what they have done. So in fact, we could access to the intentions of the pilot as well at that time. So in fact, we mixed, you know, the objective measures, as you see, you know, the eye tracking and the heart rate and things like this, and the subjective that was provided by the pilots at that time. And we were able to follow the various kinds of parameters on a schematic. I show that on this video. We showed 2 parameters, but there were more than that. So in fact, we could translate all this in the form of what I called activity analysis. We could transform, you know, the initial task analysis in the form of a BPMN into an activity analysis in the form of the BPMN. That was, you know, very interesting to visualize the differences of what they've done with what was anticipated. So, in fact, this comparison enabled the discovery of what we called emergent functions. So in other words, a function is what transforms a task into an activity. This is a definition. You know, I gave that in my previous webinars, so I don't want to come back on the theory. So, but these functions, you know, that we anticipated were run usually pretty well, except that there were some episodes where the pilots had to activate some other functions that we call emergent functions, and that we had to consider in order to see if there was necessary to transform the system's knowledge, if you like, you know. So, so we call that the activity analysis plus. So in other words, this is also interesting. We recorded the, you know, for instance, this is the heart rate in red. And then we compared, you know, the objective measures with subjective measures provided by, you know, indices. Here we show a few of them, load indices. And we compared, you know, the load indices were very subjective, provided by experts. in the form of formula that we run. And then the objective measures provided by the eye tracking, by the heart rate, by several other physiological measures were compared. So in fact, we had this objective data and the subjective data that we wanted to compare. So here you see that, for instance, it's very difficult because we see here that there are some similarities in the, here. But what was interesting is when you analyze that in more details, when you compare the objective measure with the subjective measures, you can see that, for instance, at this point here, there is a big difference. And this big difference here is due to the fact that we didn't anticipate what we call the emergent functions. And this is where it's interesting to see that the pilots had to do differently, and they had very different cognitive output, if you like. So, so in fact, this was very interesting, and we correlated, the subjective with the objective all the time, and that was a very good indicator for the analysis and for the construction, in other words, because it's not only a human factor study here, it's also a human-centered design study in the sense that we need to use these kind of results incrementally in an agile manner to modify the virtual assistant. And then we did that, and it worked. So this is, I should have put this before. Okay, so subjective load indices versus physiological measures. So subjective load indices established by the subject matter experts. I said that already. Physiological measures such as heart rate, eye tracking, etc. And we tried to correlate, subjective and objective assessments that provide insight for trust and not trust assessment. So we continue to investigate all these kind of things. So what kind of models did we anticipate? I said that, we made the difference between the high-level metrics, the criteria, intermediate criteria, and measures, what we measure directly, both subjectively and objectively. So for the trust, we correlate the trust with criteria such as efficiency, effectivity, reliability, robustness, relevance, and transparency, etc. For collaboration, we correlate that with feedback quality, perceived relief of the task, and no discomfort. And then, again, the efficiency was measured in terms of process information, pilot actions, verified information, eye tracking, effectivity by interaction time, etc., etc. So in fact, the idea is, we build this model in order to better understand if, the concept of trust and collaboration between a human and a, I would say, smart machine. So what are the perspectives now? We developed this method that we will call later PRODEC by developing a task analysis, developing a prototype, developing human-in-the-loop simulation. So in other words, we don't develop, user models, or except for the trust and what I showed in my previous slides, but we don't develop a user model that we could actually simulate with the simulation of the machine, but we use people. In fact, real people. Human-in-the-loop simulation, I think, are crucial. I've been involved in user models for a long time. I started actually with that in the beginning of the 80s. We were certifying the 2 crew member cockpits. We were going from 3 to 2, and then we developed, human operators models. And then after that, I went to NASA, and NASA developed a model called Midas. Midas ran for 20 years with a lot of people, probably 20 people. And then I think Midas is no longer used. because they needed models to understand the model. So in fact, it's better to use, this is my view, it's better to use real people in human-in-the-loop simulation. In other words, we are able today, with all the digital media that we have, it's easy to, I mean, it takes some time actually to develop these simulators, but we can develop simulators at design time and use this simulator in order to observe what people would do with this simulator. In other words, you know, it's like if you want to redesign your kitchen, now there are companies that come with you know, things like you know, virtual helmets, you know, helmet mounted displays, and show you the kitchen where you are, and probably could modify the kitchen as you provide emergent modification that you want to make, you know. And then this is exactly the point that I want to make here. So in other words, we prefer to human-in-the-loop simulation in order to observe activity and discover emergent properties in terms of structure and functions. And then that enables the possibility of tangibilizing you know, the simulator, in other words, the system you target to be done. You know, I will show you in the next use case how we can do that also. And then you build a knowledge-based, procedural and declarative that you keep. On the other side, you have the metrics, because you need to measure something in order to validate things. So in other words, you cannot do without developing metrics. So we'll come back on that. So this is human factors and ergonomics. This is the product method. This is the formative evaluation that you have to make. And this is about agile development. I already talked about this concept before, but here, this is an implementation. So in other words, we develop a systemic ontology that enables optimal definition of HSI metrics. That goes together. And this is, you know, that requires iterative steps and constant assessment. This is a work in progress. And we continue to develop this approach on the future combat air system, European. Now, a second use case, oil and gas telerobotics, and this is based on PRODEC. And this is a research effort was sponsored by Total Energies. And this was done within my chair at Central Supélec and Estia. I leave you with this movie.
We are at Shetland Gas Plant, which is where we process the gas from our Lag and Tormore fields. And what's happening today, well, we have a robot on site for some live SATs for a site acceptance test, where a robot is going to come and join us for the next 12 months and hopefully beyond.
Total E&P UK was very motivated in supporting the development of robotics. Thus, we went together in the development, and this ended up by the test of the robot in the Shetland Gas Plant, which offers a very difficult environment, thus a very good opportunity to test the endurance of the robot.
One of the main benefits of having robots is the opportunity on a high-risk oil and gas facility is to allow our team to work in a safer environment.
The robots will approach their area of operation, which is a desalination module, autonomously. They will climb some stairs there and then drive from checkpoint to checkpoint, taking a picture. It will upload the picture to the cloud, where it is evaluated. And then after a series of checkpoints, the robot goes back into its docking station and recharges.
we're very excited to have the robot on site. You know, we feel very honoured to be the first site, not only within Total, but also within the industry, to have a live robot for the next 12 months. You know, we plan to get up to speed on the robot to really get the robot doing some really valuable tasks.
So it really is an innovative project. It's using robots where they've never been used before. We're working at the cutting edge of technology. So I think using high technology and robots really complemented that, and it gave us the opportunity to be at the forefront.
So I stopped the clip here in order to say that this project is about replacing people by mobile robots. In fact, we are working with you know, in a use case of on drilling platforms on the ocean, where it's very extremely dangerous. In fact, they want to actually decrease the danger and radically by removing the people and replacing by robots. But the problem is that doesn't remove the people from remotely. In fact, we need to design operations room for that, and we need to anticipate, you know, the various emerging properties of this kind of thing. So in fact, we use product that combines procedural operations experience. I mean, the people who are doing this kind of thing right now, you know, the drilling stuff, and try to anticipate, you know, go from as is, as I said before, to be in the future by declarative engineering methods. In fact, the idea is we want to develop. I mean, we developed actually simulations, initially software simulations, and incrementally we had the chance actually to have a playing platform, you know, in Lac in the south of France. It's a village called Lac, and previously was a drilling of gas, natural gas by Alpha Aquitaine, and now it's Total Energy. And then there are 3.4 hectares of simulation facilities, you know, physical facilities, and then we tangibilize incrementally from the software to the hardware stuff. So in fact, we took I take an example here of ping launching. It's not only mobile robots, but it's also very, you know, sophisticated. Let me, you know, this is what we mean by ping launching. This is a, you know, this is the task is cleaning, you know, tubes inside. So in fact, all this is done by people right now. You know, they put this kind of thing inside. They open the tubes and they verify that it's very well done. All this should be done by robots in the future. Okay, I think you understood the topic. And I go to next slide. So in fact, the idea is what we do at this point is not only a pilot facing a virtual assistant, is actually trying to model a multi-agent telerobotic system. Then we proceed exactly the same as for the previous example. We had domain experts, storytelling, GEM sessions. GEM is a method that I've developed for a long time, 25 years, to elicit knowledge from experts. And then we build the physical and cognitive structure and function, you know, things, and then we run what I showed before. So in fact, this is the field I was talking about in Lac, you know, these 3 hectares of fields. That and then we developed the simulation, and we implemented what is very well known by human factors specialists, the Wizard of Oz there, that mixes you know, some real features with simulated fake, if you like, features. This is the real platform on the ocean. Then we want to go from there to there by tangibilizing the you know, the simulation that we are incrementally developing. So in fact, for the the ping launching, this is a, you know, in luck, this is a real actually ping launching, but it's fake in the sense that there is no real oil in this. I mean, we put some kind of liquid that is not so dangerous. And then we developed the digital twin of this equipment. And then we simulate, in order to simulate what the robot should do. So in fact, we do the first as-is with the people, and then the to-be with the robot. So in other words, I pass very quickly. The objective of this study is to specify a new operating room and to identify human operator skills for the people to manipulate these robots. And in return, we want to develop the functions of a robot that needs to be implemented. So we start with as-is scenarios. We develop the to-be scenarios. We run the human-in-the-loop simulation. By the way, this is scenario-based design. This is what I'm going to talk about next time, more theoretically. So in fact, we come back on the schema that I showed initially, where we start with a task-based procedural knowledge, as is. We build something, the to-be, with the robots and the operating room. And we run the human-in-the-loop simulation. And then we observe the activity that will be transformed into task, and then we iterate one more time. So in fact, I will not spend too much time on this. There is a lot of details there, but the as-is modeling involves a familiarization, choice of representative case studies. In this case, I mean, the pig launching, for instance, this is one, but we had several others. The data collection that needs to be done, and we had to develop some sensors, and exactly the same as for the air combat system that I showed before. We had you know, this eye tracking stuff and everything for the people. And then the modeling of the functions, you know, and all this show the functions that we extracted for the as-is for what exists today. You know, I will not read the functions that we have with the definitions and the cognitive resources that are expected. And then we model the to-be, and then we run the simulation. For the for the to-be, there are a few functions that we defined. And then by developing the human-in-the-loop simulation, we did use the BPMN of the activity, and we discovered some emergent functions that we included in the next iteration. So, okay, so this is what we call BPMN modeling. So in fact, all this is based, again, on human-in-the-loop simulation. And the tangibilization often requires magic tricks. In fact, we need to, you know, creativity is very important there. We need to have people and who are creative enough to say, well, here, I suggest to do this. And then we worked really together. There was really good study in the sense of participatory design at this point with the oil and gas people there. And believe me, my team in the beginning was not very familiar with oil and gas, but we are working with them for more than 3 years now. And then today, I mean, we can talk with the people, and sometimes the people say, "But you are from the field." we incrementally learned a lot, you know, in the development of this new telerobotic system, and you have to learn about oil and gas as well. Actually, this is important. So I pass to the next. Okay, no, I still have. So human-in-the-loop simulation, of course, yeah, and context is a very important thing. So in fact, you know, I already talk about context of use of things, you know, and all this has to, you know, was very important to develop here. It's not finished, but very far from being finished. But we have several rounds to define, you know, the normal, abnormal, emergency situations that could be possible. And then by making it concrete and real as possible, tangible as possible, then we came up with some solutions. So again, the advantage of ProDeck, I mean, this method, well, first of all, I should say that the oil and gas people we worked with in Pau and Lac now are very, very excited to continue, and they talk about product to at large within Total Energy. It enables preserving the purpose of the operations. This is important because the people, they know that this is a revolution to put these robots on the platform. But in fact, it's important to have an evolution for the decision making, and because they are very dangerous situation. We don't want to pollute the ocean with some very misleading actions. So that enables to reallocate functions, and this is recognized within the Total Energy right now. The shift from ASIS to 2B is very well understood right now in terms of BPMN, in terms of human-in-the-loop simulation, things like this. And then one thing that we did not anticipate is that ProDeck is a very useful method. By the way, ProDeck will be explained in June in the scenario-based design. But ProDeck is very useful for training. That was very interesting. We discovered that we elicit, these functions, emergent functions, and that are very interesting for training purposes as well. Because even if we robotize this, the drilling staff and maintenance staff, then there will still be people manipulating the whole thing remotely. So in fact, the work in progress right now is one step ahead, is the development. We're going to use this approach for the development of two platforms. I cannot tell you where they will be, but they will not be in France. It's and for developing these platforms, I think starting next summer. Use case 3, remote maintenance of helicopter engines. So this is a research effort sponsored by Safran, and this is done within my FlexTech chair. So the idea behind this is to develop digital twins of helicopter engines. When you have a maintenance operation, and a helicopter doesn't work anymore or has problems, then the company or the people who are owning the helicopter, called Safran in this case, and say, well, could you fix that as soon as possible? So for a long time, the people were, flying there and looking at the engine and trying to fix. I mean, the experts are really good, but they need to see sometimes what is going on. If you have a sun absorption problem or a big snowstorm in the north of Canada, and the people didn't use properly the procedures, for instance, and things like this. So in fact, today we have developed this digital twin of helicopter engine, and then we can run the simulation and try to test, to put back in the form of a simulation what the people have done. And with respect to the result, we can better understand what the people are talking about. So in fact, there are various stakeholders there: the customer, the field representative on the site, the service engineer, the diagnostic engineer, and the health monitoring that is actually at Safran. So in fact, we build a digital twin of all these actors, including the technology itself, I mean, the helicopter itself. And then the idea is, can I be aware of what is going on? What happened, that caused this failure? So we took this, what Mika Hensley. Mika Hensley is a lady who actually developed for more than 25 years the concept of situation awareness. So perception of elements of an environment in a volume of time and space, understanding their meaning and projection of their state into the near future. So in fact, what do I understand, you know, and the idea is we develop the digital twin as an image of the physical twin. I mean, in this case, the helicopter engine. And then we had a PhD research effort performed by one of my students, Stelian Camaradit Pinto, who is now in New York, but he spent 3 years with us in the FlexTech chair. And he said a digital twin is a dynamic representation of a physical system using data, models, and interconnected processes to enable access to knowledge of past, present, and future state to manage action on this system. So in other words, the idea is we can use the digital twin in order to represent what is going on in the data that I receive. So in fact, all this needs to be represented in the form of systems and agents. I already showed that in my previous presentations, webinars. A system is defined by a structure and function as a role, a context, and as subsystems, you know, resources that could be physical or cognitive and could be also human or machine. So in fact, a system could be a human or machine. And then could be, you know, the analysis is on two spaces. One is the system space and the other one is the context space. So in fact, we use this approach to represent, you know, the task analysis, the agent journey that we call, and the scenario. Again, I mean, this is a scenario-based design approach. The scenario as is and the scenario to be for the various agents, and then we run that as a simulation. So what happens here is, in addition to the other things, the development of a digital twin of people as well, okay? Human-in-the-loop simulation, activity observation and analysis, this is the same as before, and incremental agile redesign of the digital twin. I just remind you that in the systems engineering community, we have now this association of systems engineering, SE, and artificial intelligence, AI, and we have this vocabulary now, AI for SE, SE for AI. In other words, I mean, we use some AI algorithm actually to run this simulation. Systems being agents, you know, system for system engineering, agent for AI. So this is work in progress. We have a PhD student working on this, it's Quentin Laurent. It's continuing. We have a fourth use case here. That is...
Guy, you are very well on time. It's still 12 minutes to go.
Okay, great.
Yeah.
Use case 4 is about remote and virtual air traffic control center. By the way, it's not civil, it's military. We're working with the French Air Force and the company CS Group on this. And this is sponsored by this. And this is done within my chair, FlexTech. So in other words, we are working, you know, in the military, you know, they have air traffic control towers, like in the civilian world. What they want to do, and they are already doing, mobile virtual tower. It's a truck, you know, and then they have sensors that needs to be located properly. And then the goal of this project is to work on three things. What kind of sensors? Where should we locate the sensors? Second, how can we fuse the information from the various sensors, data fusion? And the third is representation on screens. I mean, should we represent that in 3D, 2D, noise? I mean, whatever. So in fact, the human, if you like, the human computer interaction stuff, this is. So the objectives are cost saving, tower construction, but also mobility, pooling of resources, same center, several airfields with low traffic volume, possibility of regarding deployments, military external operations, isolated areas, system performance, provide controllers tools that were not available in traditional tower. In fact, the idea is to augment the information quantity or quality. Sometime in the military, we talk about augmented cognition, if you like. These are examples from this stuff from the civilian world that we are trying to get some information from. The idea is, we try to better understand at this point the as is. What do we do today in traditional control towers and control centers, and what could we provide to augment this and for mobile air traffic control centers. Okay, so and also there are some subsidiary things. What kind of sensors, camera-based, etc. Alternative interaction concept, not necessarily only visual. So we are working on the 5 senses. Consider roles of controllers, technicians, pilots, and non-human elements. So designing a virtual center as a complex socio-technical system following an HSI approach. So all this is not very old. We started 1 year ago. So in fact, we may actually ask you some advice, but I wanted to show you that we are using the same approach as for the other cases. So we try to better understand the emerging properties that come from the activity. And for that, we needed to develop a simulation facility, which is currently developed. So the idea is, how can we incrementally modify the various points, the sensor location, the fusion, the presentation to the human controllers. Then we started to develop this as-is BPMN, exactly the same as before. And then we are starting to deploy this human-in-the-loop simulation. So basically, the process is the following. So we develop the as-is model. We try to better understand where to virtualize this. What are the things that are very interesting to virtualize? How do we elicit the various properties? We do the task analysis. We develop a bootstrap virtual environment. Then this is now a big thing that we run collaborative sessions to elicit the to-be scenarios. So in fact, there is a competition between creativity of people. People are not necessarily experts, and experience and expertise that is more conservative. So on one side you have the creativity, on the other side you have the experience, and then we try to combine these kind of things. And then we run the simulation, human-in-the-loop simulation, do the activity analysis, and incrementally refine the whole thing. So this is not different from what we have done before. The thing is, what we create at this point is a digital twin of the virtual control center. And this digital twin is very important for many reasons. One is to better understand the emerging properties. but also to document what we are doing. In other words, the technical documentation and the operational documentation are included into this digital twin in the form of, you can replace things, or you can say for training purposes, for instance, this is very important. You can show what could be done, or should be done, must be done, things like this. So this is work in progress, and we have a PhD student, Alexander Didier, is working on this together with the Air Force and CS group. So we have, I'm going to finish here. We have 3 more projects I want to mention. I don't have time to enter into details. One is InnoMed. It's about I have a slide for that. Reinventing a new health system in France that put the general practitioners at the center of the system as filters for the hospitals. Today we have long lines in the emergency centers of the hospitals with people who are not necessarily sick and other that requires emergency immediately. So in fact, we would like to regulate that by reconstructing, having a systemic approach of the health system at large. Another one is the FCAS, the Future Combat Air System. So this is something we do with Thales, and so I will not talk about that today. I mean, I have a slide for that. So, and then the last one is something we started last year with the SNCF, is a French railway company. And we call that model-based HSI of highly automated cranes. So the idea is, they have a new automation perspectives, and they want to, okay. So come back on the InnoMed. This is a collaborative system, and we are working on this for the last 3 years. And we worked on this with master students and people. I mean, the people of the emergency SAMU. I mean, it's called in French SAMU. Emergency people in the Basque area, and so more later. If you're interested, we can talk about that. For the SCAF, I mean the FCAS, sorry, the Future Combat Air System. So this is an ongoing thing. So we are taking this exactly as for the oil and gas. This is a multi-agent system with fully autonomous drones, and then also fighter aircraft. And we are developing a digital twin of the overall system. For the trains, so this is a starting project right now, but for 3 years we have started. We have a PhD student working on this, and we are working together with the SNCF Research Center in Paris. We have started to develop this first BPMN procedural knowledge. And we have a simulator of the train, several simulators, in fact, already, and that we are working on to transform in order to see what is going to be useful for the discovery of emergent properties with automation. Okay, so I don't have time to develop all this. So these are references I can leave in this. There is a PDF of my presentation, so you can read this. And there are more very specific papers that I can provide. Some of them, unfortunately, I need to ask permissions to the various companies and institutions that are sponsoring us. Thank you very much, and this is time for discussion.
Thank you very much. The amazing examples which they talk to our business is not just I think there is quite a commonality, and it shows that the methodologies that you have created for human system integration works in various industries. At least the example 4 with the remote digital towers, even for the military air traffic controller, they're directly spot on. And I think there is no magic solution. I think you don't have a magic wand. It's hard work in modeling processes, using task analysis, and again prototyping, and use what is you have created in this toolbox. Thank you very much for that. And we, as I mentioned it in the opening, we promised the audience that this is not the last webinar with you for sure. There is one question from Ionuț. He said, Andrei, I clearly see the HSI as a solution for developing UAS air traffic management sector, the unmanned airborne system air traffic management sector. Did you know any country asking for the human system integration approach in order to plan, practice, and develop their use space architecture? I mean, have you seen or heard or designed a digital twin, let's say, for the UAS air traffic management? Or what is your thought on this matter? Thank you very much.
Okay. So, as you know, I am chairing the Human Systems Integration Working Group at INCOSI, the International Council on Systems Engineering. And so we have a meeting almost every 2 months, sometime every month. We are developing a primer, if you like, a handbook for HSI. And within the group, there are people in the US, especially at DoD and NASA, who are using exactly the same kind of approaches. NASA JPL in California, the lady in charge of that is So-Young Kim. She gave a very nice keynote during the last HSI workshop in Torrance, in California, in November last year. So in the DoD and also MOD in the UK, they are developing the same kind of approaches for the military at large. It's not only aviation. It's not only aviation. It's also terrestrial air combat. Sorry, terrestrial combat. Sorry. Yes, there are many cases right now. They are not necessarily using the same terminology, but today in scenario-based design, the ASIS and 2B is selected as a really a good set terminology. Emergent properties and behavior is also very much used, and so everything I presented is more and more shared around the world. And in fact, within this INCOSI HSI working group, 2 years ago, we had a workshop, and we had 350 participants, for during 3 days. And that was really a good mix of things. So we are, in other words, I mean, it's not totally stabilized, but I'm talking about the terminology and everything. We are trying, and but more and more, all what I'm talking about is becoming very persistent. We need to first to document the design and document the operations. So in other words, for a long time we have technical documentation that is about how the system works and is designed, and operations documentation that is how it should be used. Like in aviation, in Airbus, has a document called the FCOM, Flight Cooperation Manual. This is operational. And then here, the digital twin approach is a combination of these kind of things, but in dynamic. It's dynamic. You can ask, what should I do in this case? Why should I do that? And then you come back to the technical documentation. You can have a video or an animation of why you should do this kind of thing this way and not the other way. That's the kind of thing that we are targeting. This is a big enterprise, but this is HSI is about trying to include, to make sense of what has been done and what we should do. I mean, it's I don't know. Did I answer the question?
Yes, I think, I mean, you mentioned one because it was one of the question of your notes. You said if you know any country in the world, so US and in your committee of practitioners, these guys in US, they do this HSI for the UIS in US. And then you said your thoughts. Thank you very much for that. We have a couple of
Israel as well. Israel as well is working on it.
Okay, so Ben Willems is asking, I have noticed that very few go from the examples that you presented, very few go through the trouble of doing a detailed task analysis. What tools have you used to make that easier, and especially to compare as is with the transition and to be?
Okay, I did mention that. For the task analysis, we have a representation called the I block, interaction blocks, that emphasizes the context of use of this, the task, the triggering conditions, when you start the task, the actions that needs to be performed, and then the final conditions that could be normal or abnormal. Normal is actually the goal, what you need to reach a goal. And then the abnormal are discovered either anticipated because of experience or observed during the simulation. And this is where the emergent properties comes into play here. And then this representation is done at the moment in the form of BPMN. But we are developing right now a platform that is more precise and that enables to link these I blocks with cognitive functions. Cognitive functions is usually represented by a role, context of validity, and resources that are other cognitive functions or physical functions. It's a kind of complicated. It's difficult to present in 1 hour all these kind of details. I tried, but within during the next presentation for the scenario-based design, I will enter into more details there. But this is complex. So we have this representation, and it starts to be very satisfactory in order to discover, the emerging properties. So because when you develop a BPMN graph for the task, and you compare with the BPMN for the activity produced, then you start to see the bifurcation very quickly. And most of the time is you can superimpose one on top of the other because there are very few emergence of other things because it's easy to do, or but when you have an emerging functions or an emerging property, then you see that immediately. And so that doesn't remove the competence of the HSI specialist. you need to be competent in the field and to be competent in the analysis as well. I mean, it's not magic. The system will not tell you, here you have an emergent property. Okay, look at that. No, but the support that we provide, the representation and the analysis, then supports the discovery of this, and discovery is the right word. The discovery of these emergent properties.
Thank you very much on that, Guy. Two more questions. The one from Jane Yeo, it said, could you share some similarities and differences between aviation and rail with the HSI? And maybe from the two examples, that fully automated cranes and remote tower operations for the militaries. I guess the complexity is different.
This is a very complex question. The thing is, there are lots of differences and lots of similarities. In fact, differences are in, for instance, in civil aviation, you have lots of procedures that are very stable. and then you can you know recognize something that is abnormal or unexpected or things like this. In military aviation, especially fight, the fight aircraft, this is the opposite. In fact, they have procedures, but most of the time is, they have to react immediately, and they have to consider problem solving more than procedure following. They are more in problem solving mode, and then that doesn't mean that in civil aviation you don't have problem solving, but most of the time it's very proceduralized, and that's the difference. But in both cases, you have procedure following and problem solving, and this is why my third webinar on dealing with the unexpected is there. So in other words, you need to support the unexpected, and probably in civil aviation, the unexpected is more rare, if you like. But are you prepared to that? I mean, if it works most of the time, then you have to recognize an unexpected situation. So most of the time it's good. I mean, but support is very important. So in military missions, if you like, you have you don't have friends around you, So in fact, you have to anticipate all the time what could happen wrong, and really unanticipated. So that's major differences. For the rail, I'm not really an expert in rail, except that I take the train more than before now. But when I go to Paris, in the rail system, there are two limits, in fact, in human factors operations. In the human factors dealing with operations. One is the high level stress, the stress level, and the low level is vigilance. So in other words, when you are doing something, if you are doing too much, then you have a limit, a top limit that is the stress limit, and over that, I mean, it's unmanageable. And then you have a lower limit that is vigilance, where if you go under the vigilance, you get asleep. In fact, this is so. In fact, you have to oscillate in between the two. And then the thing is, all this is makes differences between aviation, rail, and automobile, for instance. Also, the vigilance level and the stress level are sometimes not defined in the same way. I mean, that's the thing. So that's and then we have to control that. And one of the things that we discovered during these HSI studies is the correlation between objective methods and subjective methods. Also, this is important. So we would like to equip the people with sensors and things, but do they mean something interesting? The results, it's all questionable. So we need to correlate objectivity and subjectivity. Subjectivity is about meaning, it's about making sense. But making sense from a human perspective means that it's subjective at some point. So all these kind of things needs to be correlated. And then there are lots of similarities on this from one field to the one domain to the other, one sector to the other. But I don't know how to answer this question more than that. I mean, it's really difficult because we need to take an example and talk about it.
Thank you, Guy. I think you answered most of it. Thank you. The last question from Sebastian. In one of your drawings, you had included system parts of the Xbox. Is it part of possible solution of HSI to integrate hardware or concepts of the gamer's world into system engineering solutions?
Yeah, The idea is, well, if I understand the question well, I'm not sure I understand it, but what I understand is, I reformulate. Could we use HSI to design hardware and software solutions, right?
But using, principle of games like Xbox, I think it was one of your drawings, or maybe you wanted to present something else than the Windows Xbox. Or
yeah, I'm not really sure. I'm not really sure I can answer this question. I'm sorry.
All right, but go ahead with your first thought, and then I think we conclude with that.
Okay, what I think is, when I said, you can simulate an aircraft, with software, as a piece of software. And well, we have done that for quite a while. The Falcon 7X have been designed as a gigantic piece of assembly of pieces of software and simulated as a video game and tested before the aircraft was built. So in fact, when I said you can simulate using a video game, a video game meaning when we developed this software for Total Energy, I mean for the robots. So we anticipated some possible features, and then we realized incrementally that it was difficult to handle by people remotely. But when we tangibilized this in LAC, for instance, we put real robots trying to manipulate pipes and things. We changed our first thoughts, and the virtual and the tangible should be always combined in order to better understand what kind of structure and function you need to develop for this new equipment, that you want to do. I cannot tell you more. I mean, this is my experience, and it works. I mean, but you need to have a good representation in order to follow what you are doing. This is why I'm talking about technical documentation. It's technical active documentation, in other words. I mean, it's like having a video game that tells you, okay, you're doing this now, or or what you should do that, or this kind of thing. So in the past, all this was documented on paper, but it's very difficult to use. Today we can do much better with this. We can use the digital to help designing things and documenting things and explaining. I mean, a support to explain. I mean, the machine will not explain. I think the machine will provide insight or information for you to explain what is going on. So that's we are not in the full AI world yet. I don't know if
you allow me a joke at the end, it will save also many trees by saving printing the paper that we can't really use on. It will be much easier to be digital. Guy, fabulous. Thank you very much. As announced already, we have dates for the incoming webinars, which will be part of a longer list of other webinars with other interesting people. But you can already book in your agendas, and until you receive the link to register, it's on scenario-based design. It's on 5th of June, in the same time like today, around 1500 Central European time, to allow different time zones to connect. From all the team here in Brussels and in Germany, from Jörg, Klar, myself, Stein, and of course Guy, a big thanks for all the participants. Stay tuned, and thank you very much. So see you at the incoming webinars.
Thank you.